Okay, in this video we're going to look at polymers, which are a group of molecules that we probably often call plastics. Most of us call plastics in common language, but actually polymer is the more accurate term because not all polymers are in fact plastic, which is a type of material property, which we'll talk about later. So the first sort of real widely used polymer that was a thermosetting polymer is known as Bakelite. Bakelite was made by mixing the two monomers together, and it sort of set into that shape in the mold straight away, and that's why they call it thermosetting, because it can't be remolded once you've sort of made it, whereas some thermoplastic things can be remolded, which we're going to look at in a minute. And Bakelite was used to make things like telephones, but they even started making stuff like jewellery out of it and everything, because it was a brand new material. Everyone was very excited about it. So you can see the structure of it here. And those of you with a keen eye can sort of see that it's made of repeating units, which go again and again like this. And we call these repeating units monomers. And the polymer is the effect which we get when we put them all together. So you get them together called a polymer. Poly meaning many. And so these chain together, and then they obviously, on this one in particular, they cross-link over to another chain. Which would give rise to particular properties. And these chains form massive molecules. We're talking about, thousands of monomers long, potentially, but as small as hundreds sometimes. So if we look at the formation of this, if we look at a monomer turning into a polymer, this one's the most basic one you can get. So you start with an alkene, and you have a carbon-carbon double bond here. This one's chloroethene. And then if we put them together, more than one together, they'll form up a chain of monomer units. And we show this with brackets and the symbol N to mean N number of units. And now we have polychloro. Pretty straightforward, really, the naming of it. And so the way that this happens is that one of the carbon-carbon bonds breaks, and it forms a bond with another monomer along, and this effectively chains them together. So let's have a look now at what we mean by thermosetting and thermosoftening or thermoplastic. So thermosoftening or thermoplastic is where the term plastic comes from. But actually we should be more accurate in saying polymers. Thermoplastics have basically no cross-linking between their chains. So this means that the chains are able to slide over each other, and they're not in a fixed position as much. So it's a flexible material. It also means that the intermolecular bonds between the chains are weaker. And so if we need to, we can heat these up and remold them and reshape them as necessary. So this is really good for recycling. Thermosetting plastics, like Bakelite, once they are set, once they've been made of the monomers, they are fixed in that position. They cannot be remelted as easily, and this is because they've got strong covalent bonds or strong intermolecular bonds between the chains. And this means that they cannot be as flexible, and they're often stronger and harder than the thermoplastics. So plasticity is to do with the flexibility, and so that's the difference.